9.2 Reflections. Okay, I think this is going to be a nice change of pace and go rather quickly. All right, so reflections are the second type of transformation. The first one we did was translations or a slide. We simply slid it across our coordinate plane. Reflections, some important things to remember here, is the size and shape stay the same, but we flip our figure across a line. And so in this case, its orientation reverses. Now our translations, we just slid it, it was the same direction. So when we flip across that line, the pre-image and image are congruent, but have opposite orientation. Now, you can tell if they are opposite orientation, if they are flipped, if your corresponding vertices read in opposite directions. So on our pre-image here, remember pre-image is the original, we read triangle B, U, G, and that goes around in the clockwise direction. And we flip it across this line here. We just flip it over. And then when we read our image, it's B prime, U prime, G prime, same order, but it goes counterclockwise. Probably would have been a lot easier if we'd used more than a triangle, but that's okay. You can see the idea here. All right, let's look at our key concept. A reflection across a line R, which is called the line of reflection, go math. A reflection, when we take our image, our pre-image, and we reflect it across this line of reflection, is a transformation with two properties. Now first, if point A is on line R, so our line of reflection goes down the middle here. This is our line of reflection. This is what we're flipping it across. If point A is on this line, we just flip it over. Then the image of A is itself. A and A prime are the same point. Okay, that's easy enough to imagine there. This is the important one here. Point B, which is not on line R, then R, line R here, is the perpendicular bisector of segment B prime. Let's look at, we're taking B and we're flipping it across our line of reflection here, and it ends up over here. Then line R, our line of reflection, is perpendicular and it bisects this line, this imaginary line, between our pre-image and image points. The pre-image B and image B prime are equidistant from the line of reflection, right? Distance is measured perpendicular. When we flip it across, they are equidistant from that line of reflection along this segment that is perpendicular to our line of reflection, and if we measure our 2 points, they are congruent as well. A reflection is an isometry. We have not changed the shape or the size. Both size and shape are congruent. Size and shape are the same thing, but it does have opposite orientation. All right, let's look at an example here. It says if point P, which is at 3, 4, let's go find our point P. Point P is right here at 3, 4, is reflected across the line y equals 1. Now we know that y equals 1 is a horizontal line at y equals 1, just like it says. We want to reflect across that line. This is our line of reflection, line of reflection. So what do we know about point P? Well, we know that this line that it reflects across is going to be perpendicular. And guess what? We have horizontal lines, so vertical lines make it perpendicular. And it is equidistant, so we can just simply count here. 1, 2, 3. Okay? And then we can count 1, 2, 3. And we find P prime. P prime is over 3 and down 1, 2, negative 2. Because remember, our line is up 1 above our 0 line, above our x-axis there. So we moved it 3 spaces. So our pre-image is reflected perpendicular and equidistant across our line of reflection. All right. And that's all. Pause the video, do the next problem. All right, this was pretty straightforward. We want to know what is the image of P at 3, 4, so that's our original point up there, reflected across the line x equals negative 1. So we know that x equals negative 1 is an up and down line, right here, the yellow line, that crosses the x-axis at negative 1. So this time I took my point P, and I know that it's going to be perpendicular to my yellow line. So my yellow line is vertical, so I know I need a horizontal line to make it perpendicular. And I move 4 spaces to get to my line of reflection, so I move 4 more spaces. And that is actually at negative 5, 4. Now let's do something a little bit fun here, a little bit extra. Let's take our original P prime from the first one, and let's reflect it across our line x equals negative 1. So we know it's going to be perpendicular, and we move 1, 2, 3, 4 spaces, and 1, 2, 3, 4 more spaces. What are we going to call this one? Remember, a second translation would be P double prime. And so that one is going to be negative 5 down negative 2. So we kind of did a little extra on the problem here. Negative 5, negative 2. Now what do you notice about all of these reflections? When we're reflecting across an axis, notice that on our first one here, from P to our blue P prime, our x value stayed the same. And we changed in the y direction because that's the one we were moving. In our second translations, both of them here, we were reflecting across the x-axis, across a vertical line. So we moved along the x, and our y values stayed the same, but our x's changed. So that's just a little quick check. You can say, am I doing this right? Are my points correct? So those aren't too bad. All right. How do we graph a reflected image? Well, we just do a whole lot more of what we just did. Let's look at our example here. We have triangle ABC, and our points are graphed there and connected, and we have a triangle. And we want to know what the image of ABC is reflected across the y-axis. So I like the yellow here because that gives us more colors. So we are reflecting across this line right here. Well, the first thing that we know is that B is on the line of reflection, so B and B prime are going to be the same point. The next thing we have is A is on the left side of the line, so we are going to reflect it across the line that direction. But C is over here. C is on the right-hand side, so we are going to reflect it this way. So you can have a line of reflection that goes down through the middle of your figure, and you just take each point and reflect them individually. So as we saw, point B becomes B prime because it is on the line of reflection. Point A moves over 1, 2, 3, so we move it over 1, 2, 3. So point A ends up over here. Point C moves 1, 2, 3, 4. So we go 4 more to the other side. 1, 2, 3, 4. And point C ends up over here. So we have our image, A prime triangle, A prime, B prime, C prime. All right, pause the video, try it yourself. Now, before you start, I'm going to give you a hint, and I'm going to tell you to redraw your y-axis right here. Make this your y-axis and ignore that over there. All right, hopefully you got that hint. Okay, I graphed my triangle ABC, and then it says to reflect across the x-axis. So this is my x-axis here. I drew in my line of reflection, and then I know to reflect that I need to draw in a line perpendicular to my line of reflection. So I drew my vertical lines down from my points, and then I simply counted A went down 4 to get to the line of reflection, so I counted 4 more and plotted A prime. And A prime is going to be over here at 1, 2, 3, negative 3, 1, 2, 3, 4, negative 4. B went down 2, so B prime is over 0, down 1, and C prime is over 1, 2, 3, 4, down 2. Now let's compare those to our original points. A here is at negative 3, 4, B is at 0, 1, and C is at 4, 2. Notice how all of our x's stay the same, but our y's, because we reflected across the x-axis, all of our y's are simply the opposites. So that's kind of fun. All right, let's look at our next problem here. This is math being useful. Minimizing a distance. So geometry is useful here. It says beginning from a point on Summit Trail. So let's look at our trail here. Here is Summit Trail. So beginning from a point on Summit Trail, a hiking club will build a trail to the overlook. So we want to get a trail that goes over here to Overlook and a trail to Balance Rock. So we want to get here. And we have to start from Summit Trail. And it says we're working under a tight budget, so we want to minimize the total length of the two trails. How can we find a point on the trail where the two trails should start? And we're going to assume that they will be straight and they will cover similar terrain. So not a lot of ups and downs. We could put the trailhead anywhere on our original trail here, Summit Trail. Okay, but we want a trail that is the shortest. So what we are going to do is we're going to find a point P on line T, that's our Summit Trail, such that O plus P, and OP plus PR is as small as possible. So we need to locate O prime. That's the reflection of O across T. Because this is going to be, right, our line of reflection is the perpendicular bisector. And using our triangle inequality theorem, remember that? It says the sum of any two sides is greater than the third side. This length is going to be the smallest when all three of these point R, P, and O prime are collinear, because that's the smallest a triangle can get. It's not even a triangle then. All right, so what we want is we are going to take O and we are going to reflect it across our line of reflection here. So we know we need to be perpendicular, and then we would just get out our ruler and we measure our distance across and find O prime. And then we know that if we draw a line between O prime and R, that where it intersects our line of reflection is going to be the shortest distance. Now, can you see why this is true? Look what we have here. We have an isosceles triangle. And that is going to create a minimum distance for us. So we will actually ignore all this stuff on the left, and our trails will just be here from R to, this is point P out here, and then P to O. All right, pause the video and ponder the last question. All right, we are asked, your classmate starts to solve the problem by reflecting point R across line T. So, will this method work? So she wants to take R and she wants to reflect it across line T here and says we'll still be fine. Will that be okay? Well, yes, of course, because all that's going to do is make R prime over here collinear with P and O, instead of O prime being collinear with R and P. So it's just a different isosceles triangle. You can see right here that these are exactly the same things. So it doesn't matter which one we reflect, we end up with a nice, neat little trail that comes here to point P, and it goes up here to O, the overlook, and we have spent as little money as possible to make our trail. Reflections, especially if you're doing them on a coordinate plane, are rather simple. Just remember to draw a line perpendicular and then move the same distance. Let's say that our line of reflection here, this is our line of reflection. We'll call this line L. Okay, and now we want to reflect both P and P prime across our new line of reflection here. So how are we going to do that? Well, exactly the same. You should have seen coordinate plane and said, hey, distance formula, slope formula, midpoint formula. We need a line that is perpendicular to our line of reflection. So what says perpendicular? Slope. Perpendicular slope is the opposite reciprocal. Yeah, I knew you remembered that. So we need to find the slope of our line of reflection. The slope of our line of reflection here, that's really not very neat. The slope of our line of reflection, we just take 2 points, up 1 over 1. So what is our perpendicular slope going to be? Well, m perpendicular is going to be the opposite reciprocal, -1 over 1. So I start at point P, and I go down 1 over 1, down 1 over 1. And I now have a line that is perpendicular to my line of reflection. And how far did I move? Well, I simply went down 1 to get to my line of reflection. Okay, so I know I'm going to be straight across. On the other side, if I go up 1 or down 1 over here, this is going to be my new P prime. What if we want to move P prime here? Well, I'm going to do the same thing. Perpendicular slope is down 1 over 1, down 1 over 1. So I have a line that I know is going to be perpendicular to my line of reflection. Well, how far away is P this time? Well, it's over 3 and up 2, over 3 and up 2. So from here, I need to go up 2 over 3. We can count middles here as well, 1, 2 and a half. Right? There's my half, 1, 2, 2 and a half. This is going to be point P double prime. Starting here at point P prime. So don't forget, on a coordinate plane, you can use opposite reciprocal. You can also use distance formula. Right? Don't forget your distance formula if you need to calculate how far that you went, right? Because these need to be congruent. I think our most difficult problems use a slope of 1 over 1, and they're pretty easy to do. All right, so that's it for the extra portion of this lesson. Not too bad.